good afternoon. My name is Chidima, and I'm your host for this session. The title of the next talk is The Power of Knowledge Graphs and AI, a new era for developers and data scientists. And this talk will be delivered by Aldan Creo. Aldan studied computer science in Spain, France, and Switzerland, graduating as valedictorian. He completed 4 internships and was selected by Django as a Google Summer of Code contributor. He received a grant from the Spanish government to undertake research on natural language processing. He garnered recognition for leadership and academic excellence through several awards. He's also the founder of 3 associations and contributes to open source. Currently, he works as technology research specialist in AI at the DOC, Accenture's flagship R&D and Global Innovation Center. Please join me welcome Aldan Creo.
Hi, hello. Well, I think I'm gonna skip over the first part, which is who am I? I wanted to give you an idea, just super short. I do so basically I took my CV and I did like a word cloud on the words on the CV, right? So like I do development, science, etc. LLMs, I really love that thing, but I think that, well, yeah, I work at Accenture. It's a company that's in Dublin for tax purposes, and. And yeah, so like they do consulting, but there's also a research department. That's where I am at. So yeah, that's Accenture. I'm more interested in you, really. So I want to know, who are you? And specifically, we're going to do a bit of hand raising, all right? I would love if you could just raise your hand to tell me how familiar you feel you are with a thing that's called a knowledge graph. We'll explain what it is in a bit, but I would just love to see more or less, all right, so some variety, right? Some people know it, some people don't. Don't worry. What would you say about large language models, LLMs? Yeah? Okay, well, we have diversity. That's great. That's great. Last question. How technical do you think I should be? Okay. Well, I'll try to be not very technical, but also because we only have 40 minutes, so like I'll have to skip over some parts because I just realized I'm not going to have time otherwise. So let's just really dive into the thing. I'm going to show you what we are going to be talking about. First, we're going to explain a little bit what's a knowledge graph for those of you who maybe would like a refresher. Then we'll, well, talk about the types of knowledge graphs that there exist, how can we apply AI to them, what algorithms there exist for knowledge graphs, what can we do in the real world with those things that we'll be speaking about, what are the limitations of the AI algorithms that we apply to knowledge graphs, and then we'll see what can we do with LLMs. How can we mix knowledge graphs and LLMs? Let's start at the beginning, right? What's a knowledge graph? So a knowledge graph, it's a very simple data structure, right? It's a type of data structure that contains 2 things. It contains nodes, and it also contains links. You see here, I have a node, they are connected, right? That's a knowledge graph. We use that to represent information in this way that you are seeing here, and we can apply machine learning algorithms to them. Also, we can mix them with large language models. We can combine them. We'll see how. And that's going to be the topic of today's talk, right? That's a knowledge graph. So I hope you got the idea, right? Yeah? Good? Yeah. Fantastic. So types of knowledge graphs. What are the things that we can represent using knowledge graphs? Could literally be anything, but I'll give you some ideas. So there's things that are like Wikipedia. So knowledge graphs that encode, well, things like Barack Obama is married to Michelle Obama, etc. Those sort of encyclopedic knowledge, right? But then we also have things that are like more about common sense. Like waking up is like when I get out of bed, that's something that happens when I wake up. Things that are like more, yeah, common sense, right? Then we have things that are very specific technical domains, biomedicine, etc. And then we have those sorts of knowledge graphs that include images, other types of multimodal data. Having said that, the idea here, I'm going to try to summarize the sections at the end. So you're going to see like this type of box. This is the summary of the section, the idea that I would love you to have. Idea here, knowledge graphs are everywhere. We can use them for anything. So they are good, right? How can we apply AI to this thing? Well, we can do lots of things, really. But one of the things that we can try to do is to predict new links. So you see we have nodes, etc. They are connected. But sometimes there's things that we don't know yet. So for example, maybe I know that Barack Obama is married to Michelle Obama, but I don't know that Michelle Obama is friends with someone. Maybe I could try to predict that, right? Link prediction, that's something that we can do. Also, we can try to measure similarities between things. How similar is Barack Obama to Trump? Give me a like a number, right? We can apply reasoning processes, lots of things, really. We could do lots of things. With AI, we can knowledge graphs. Summary of the section. Next section. You see, I'm trying to go fast. So we have a thing that's knowledge graph embedding. That's what we are going to be talking about. What's an embedding? An embedding, I'll give you a super short, simple explanation. It's an idea, a concept. I have a car here. I have a slice of pizza here. They are different, right? We could represent them with numbers. So I could tell you, this is number 1, this is number 2. And that would be a way to represent concepts. But we don't do it that way. When we use AI, what we do is we take a vector. I'm going to use a lot of math here, but I would just like you to know that we have some numbers that encode the idea of a slice of pizza, and those numbers are different from the idea of a car. Right? Yes? Good. So just a way to represent concepts, really. That's it. I'm going to try to explain, this is maybe the most technical part of the presentation, but like I'll try to keep it simple. I'm going to explain 2 types of knowledge graph embedding algorithms. So 2 types of ways to extract ideas from knowledge graphs. You see, like for example, we had a graph that had Barack Obama. How do we learn the concept of Barack Obama? We're going to learn this right now. So 2 ways. The first one, translational models. That's what we are going to talk about in a second. Just short note here, there's 100 different algorithms. So like we are just going to talk about this one, which is the most simple one. But really, they get super complex. So it's really a huge mess. But we're just going to try to get an idea of what they are, sorta. So translational models. We have a graph. For example, here what we have is we have genes that are connected to diseases. For example, gene 1 causes cancer, gene 2 causes heart disease, etc. Yes? So we know that this is true. Okay, let's just assume that these things are true. But now, let's try to learn the graph. How does a machine learn the things, learn the idea of heart disease? How does it learn that concept? Well, so what we do, I'm going to put the graph here on one side, all right? And now I'm going to draw a vectorial space. Vectorial space, really just imagine it as a 2D like space, right? Like I have this grid here, and I'm just gonna literally copy paste that graph onto the 2D space. So I've just copy pasted the thing. Now, what we do with those algorithms, translation models, is that we draw arrows. So this is an embedding. This is, you could imagine it's just 2 numbers, x, y coordinates, right? So it's here, Those are the two numbers that represent gene 1. That's the embedding. Now, I'm going to try to optimize a cost function. I'll explain in a second what we are going to do exactly. But you see that we have some lines here, right? Some arrows. Those arrows represent the idea of causes. So what I'm saying here is, if I take gene 2, this thing here, this embedding, and I sum this arrow, I take the gene and I sum the idea of causes, I should get to the thing that this thing is causes, right? Yes? That makes sense. Note here, we have multiple arrows here. So you see gene 3 causes depression, gene 3 causes heart disease. All of the relations have to have the same shape. So the arrow has to be the same for all of them. But here you could imagine we have two arrows, actually. It's just that the arrow, like I can't have one arrow like this and another arrow like this. They have to be all of the same type. But here we are trying to represent this idea of this thing causes something. OK, how do we train the thing? So what we try to do is we take a link here, gene 1 causes lung cancer, and we take a look at what's in the graph. So, sorry, what's in the embedding space. And what we do is we just move the thing, you see? So we just put it here. So here we have a perfect prediction, because if I now take gene 1 and I sum the idea of causing something, I get to lung cancer. That's what I want. That's great. The problem here is that if I do that thing with everything, the perfect solution to this problem of optimization is that I just put everything in the same place, and then I have the perfect prediction because everything gets to the place that I want. So what I do is basically I introduce a thing that's called a regularization parameter, and that just basically means that I try to get right predictions as well, but also I want the things to be as far away as possible from each other if they are not connected. So for example, this thing is not connected to this thing, right? So I try to, well, put them far away. So we train our model like that, and we could get to a solution like this. I mean, I haven't run the model. I just, well, moved around things in PowerPoint, right? But you get the idea. So here, what you can see is that gene 2 is connected to lung cancer and only lung cancer. So here we have a perfect prediction. Good. Gene 4 is connected to lung cancer and heart disease. And you could actually see that, like, it gets me here, which is sort of in between of the two things, right? So that makes sense. So what we can do with that is that we can measure the distance between the place that I get to and the actual thing. So you can ask me, how similar is gene 4 to heart disease? And I can tell you it's 0.5. Gene 2 and depression, are they related? No, they are not, right? So that's how we apply AI to knowledge graphs. And then we can try to also extract new ideas. For example, gene 2, if you look here, gene 2, it's only connected to cancer. But if we measure the distance in the embeddings, we actually see that maybe there could be a relation here that is that gene is connected to heart disease. Maybe we don't know it yet. This could be new knowledge, right? That's link prediction. Actually, this example is sort of what we do at Accenture, but I just think it's a nice way to visualize it. So I hope you got the idea, right? Yes? That's clear? Fantastic. I'm going to drink some water. Give me a sec, yeah. It's just that, like, I'm trying to be super fast. I'm going to skip over half of the presentation as well. So yes, there's a lot of things to talk about. But that's the idea of translational models. That's one of the models. Then we have a thing that's called semantic matching models. I'll be super fast, really, super fast. You remember we had like a vector, a set of numbers that represent one idea. We are going to try to do the same thing. I'm just going to tell you that we have some math, some matrices somewhere, and we do some operations, and we get a number. You see it? We had a 0.5 here. We try to make everything that is true as close to 0 as possible. So we want the distance between things that are related to be as close to 0 as possible. It's the same idea as before, right? We just do it in a sort of different way, but it's the same idea. So what? Oh, shit. Fuck. Sorry. OK. Yeah, great. That's the idea. We try to optimize this cost function, and then we can use it to do predictions of things, etc. Very nice tool. So, well, that's fantastic, right? We can use it for real-world applications. Some ideas. Predicting gene disease associations, what I showed you. Drug repurposing. So I have a drug that, like, for example, aspirin. It works for headaches. But actually, if I take a really big graph of what people take for certain diseases, maybe I could actually see that aspirin could be used for something else that we don't know yet. Just one idea. I don't know, Facebook. Facebook predicts your friends, right? Google. It's literally a knowledge graph of websites and how they are connected. There's a lot. Like, if you have ideas, you'd probably come up with 1,000 things here, right? It can really be applied to so many domains that I couldn't, like, really come up with something very specific, because everything you can think of, you can apply knowledge graphs. So, applicable to lots of things. And you would say, oh, it's perfect. That's amazing. It's the best thing I can get. Well, there's limitations, right? That's what I'm going to get into now. We have limitations. And I'm going to, well, just give you an example of what's the biggest problem, I think, we have with knowledge graphs. You remember the graph we had. So here we are saying gene 2 causes lung cancer, blah, 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 blah. But what if I just change all of the words here? So that's me. I like Inception, Doctor Who. John likes Doctor Who. You see, it's a completely different thing. Not at all related. But if we remember how we trained the thing, I never talked about we analyzed the word or things like that, right? We just had things in a plane, and we moved things around, but we never cared about the text. But I think that's a problem. I think that's a problem, because it's not, like, if I'm talking about diseases, it's not the same thing as if I talk about movies. And here I'm saying likes, but what happens if instead of likes, it's hates? Should I really get the same result? That's a problem, right? That's the limitation. That's the big thing. So, yeah, they are not perfect. What can you do? Yeah, I don't know. We can try to mix them with large language models. So you know ChatGPT is great with text, right? It can produce things that are very convincing, very convincing. So everyone thought, OK, we can just try to mix the two things. That's what I'm going to try to explain to you now, but very fast. Very fast, because there's really 1,000 things that we could do to try to mix the two things. Specifically, there's like 3 categories of things that we can try to do. So we can try to augment LLMs with knowledge graphs, so make them smarter using knowledge graphs. We can try to enhance or make knowledge graphs better using LLMs. Or we can try to just put them at the same level and come up with something that's better by hybridizing the two things, right? OK, I'm going to give you an example of the 3 things. So we're going to see examples of the three things, but they are just examples, really. Like, there's more than this. More things, but I just want to give you like an idea of things that we could do. So, harvesting background knowledge in LLMs. This is something interesting that we can try to do. So, the idea of this thing is, like LLMs have read a lot of text. So, like, for example, they have read like Wikipedia articles, right? Like, I just copied this from Wikipedia. LLMs, ChatGPT, has read the whole of Wikipedia, has read scientific articles. We could say that it knows a lot of stuff. So, if it knows so much knowledge, can we try to extract that thing and put it in a knowledge graph? That's the idea. We're going to, try to extract that, and we're going to take a super short look at two systems that try to do this thing. The first one is this thing that's called Comet. It's just the name of the paper that, presents this system. The idea here is I want to get this knowledge graph, right? I want to generate something like this. So I want to generate relations of the type something, does, likes, hates, causes, something else. I want to generate this type of graphs. How do I do it? Well, I just take a language model, I take ChatGPT, and I train it. So I train it to be able to generate the object of the triple. You see, we have three things here. I'm going to train it to know how to generate the thing that comes last. So for example, here I'm giving capitals of places to the language model. I train the model, and what I get in the end is that if I ask, what's the capital of Berlin, it will tell me, oh, it's Germany. Sorry, Berlin is the, yeah, right? Yeah. So it learns how to generate knowledge, sort of. That's the basic idea. That's something that we could try to do. I'm gonna skip over this part. I'm just gonna pass this part, blah, blah. It's the same idea in the end, so I'm just gonna be fast here. Yeah, sorry. It's just because like I wanna save the time. If you have questions, etc., just I'm gonna skip over that. I'm also gonna skip over this part. Not important. I mean, because it's just the same idea, really. It's the same idea, but more advanced. Does also other things, but I would love to show you another way that we can try to combine the two things, to combine large language models and knowledge graphs. But here, what we are going to try to do is that we are going to try to aid language models with knowledge graphs. So you see, we use knowledge graphs to answer questions. How do we do it? There's a proposal that is Oreo LM. Fantastic system, really. Amazing thing. Oreo LM, what it tries to do is sort of what the word is saying. It's like an Oreo. So I have a language model, and a language model, in the end, is just a set of layers that processes text. So what they try to do is, I have all these layers, and in between those layers, I put a module that is able to interact with a knowledge graph. So it's like ChatGPT is processing the text, but it can ask a knowledge graph to get real answers. And it processes the text in that way. So it's sort of ChatGPT being more smart. It can, ask to get real knowledge before generating text. I have some diagrams here, but really it's not so important. The idea here, maybe I will show you this. The idea here is, I can ask, what cheese is used to make cannoli? An Italian thing. So if I have a knowledge graph, that contains a lot of data that I know is real, I could say, okay, cannoli and cheese, cannoli is made in Italy. Cheese, what was the question again? Sorry. What cheese is used to make the cannoli? Oh, yeah, so I want to ricotta, right? That's the answer. So I say, oh, cannoli, I need a cheese to make this thing. Well, cannoli is made in Italy. Cheese, there's a type of cheese that is whey cheese. You see, like, I try to somehow reason on the model to get to the answer that it's ricotta. But if I just ask the language model, if I just ask ChatGPT, maybe it would hallucinate and it would just say, I don't know, camembert or whatever. So the idea here is I can ask the knowledge graph to enhance my predictions. I'm gonna skip over this part because you see it's like a bunch of technical stuff that like is a little bit technical, so let's just skip. And the last thing I wanted to talk to you about is something that hybridizes the two things. So this really is taking a knowledge graph and the language model and mixing the two things. How do we do it? Forget about the diagram. Just listen to my words, okay? just trust me. We have a language model here. We have a knowledge graph here and also here. We are going to somehow take the embeddings. You remember in a knowledge graph we can have embeddings? We're going to take those embeddings and we are going to mix them with the embeddings of ChatGPT. ChatGPT has embeddings as well. Just they are of a different type, but both things are embeddings. So a knowledge graph has a certain idea of what's a slice of pizza. A language model like ChatGPT has an idea of what's a slice of pizza. I'm going to try to merge them somehow, be able to do predictions on knowledge graphs. So here, for example, I'm asking, where was Steve Jobs born? And I take the embeddings from the knowledge graph, and I mix them with the embeddings from the language model to get my prediction. San Francisco. Yep. Good. OK, I have 5 minutes left. Sorry, if you want to get technical details, we can go over that in the questions. But I think it's better to just try to give you an idea of the things here instead of like trying to cover everything. So, takeaway. Language models and knowledge graphs, lots of possibilities. Really, like it's an active area of research. It's very interesting, and there's so many things that we can do here. Like it's amazing. And well, having said that, I'd love to, well, just give you some hints on what could be areas for future work. What's next here? One question that always comes to my mind is, because most of research is done on things like this one here, you see? The Wikipedia thing. Or common sense knowledge graphs. So things that language models know a lot about, because like ChatGPT probably has seen lots of texts talking about waking up, does every day, right? But I would doubt that ChatGPT is really an expert about Parkinson's disease, sleeping disorders. Probably doesn't know so much about that thing. So are the things we just talked about really applicable to technical domains? That's something that's, well, to be explored. Other question. How can we adapt to new nodes? This is a really, so this is another problem of knowledge graphs. You remember I told you, so I had a graph, and then we like embedded the things, so like we had some things here, we learned the concepts, etc. The problem is, if you just give me a new thing, so if you come and give me gene 5, I have no idea where I can put it. I don't know where it is. So how can we adapt to new nodes? That's a problem that hasn't been cracked yet. So area for work. Uh, can we use architectures like that thing that could ask the knowledge graph to predict new things? Because it was to ask questions, but can we use it to predict new things? Maybe we could. I'm just giving you questions, right? I don't have the answers. But great question. How much do large language models hallucinate? If we mix the two things, how reliable is the result? Probably more than just ChatGPT, but what's the percentage of reliability, right? Mm, well, lots of questions, but I would say, if I have a general idea of the talk today, it would be this one. There's really lots of potential here, lots of things we can do. Well, let's keep working on that, right? I have a QR code for you. The QR code is a link to a 10 seconds form, really super quick, to give me feedback. Like specifically what I'm looking for is if you could tell me if I've been too technical, not too technical, if you liked the thing or not, because I read it afterwards and I use it to improve. So I really thank you if you could just give me some feedback on the session from today. And you can also leave some comments if you want. But while you do that, I'd love to ask you if you have any questions, because I know it's maybe a little bit, a lot of content. So if you have anything to ask, really, go for it.
What does it look?
Do you want to get, yeah?
Thank you for walking us through. I know it's a really complex topic, and you've tried to summarize it pretty well. Am I audible? Yeah, okay. Yeah, but how would you try to implement this in a real world from, I don't know, let's say I want to analyze product data for a customer. How would that look like, generating the graphs in the first place and then having an LLM integrated into it to analyze it better?
Okay.
So how does that look like?
Great. I'm just going to repeat your question to make sure that everyone can hear it.
Okay.
Because I don't know why the mic was not working very well. So your question was, and also I make sure I understood the question. Your question was, how can I really apply this thing if I have data about customer and products or something like that, right?
Let's say it's a recommendation engine or something like that.
So a recommender system. How can I apply knowledge graphs to that? So, well, actually, I was talking. I was talking with someone about that before. Well, I don't remember who, but so for example, Netflix, right? We could think about Netflix. It's the graph that we had before, blah blah blah, Star Wars. So, what you could do right now is just generate a very big graph of this person likes this thing. I try to apply the knowledge, the embeddings of all of the things, and then you can just take my embedding and you can ask the graph, what's the thing that this person likes? And you will see that you will get some answers like Inception or, those things. So that could be a possible application. That would be just knowledge graphs, no LLMs at all. You could try to, well, use so there was this system here. This one could be an idea to try to integrate the two things. So, I mean, I'm not getting to the details, but really what you could try to do is you have your embeddings of, I'm this person, this is the concept of being me. And I try to mix that with for example, the description of Star Wars. So Star Wars, I enrich that thing with the description of this movie is about science fiction and blah, 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 blah. And then that embedding becomes more informative. it's smarter, let's say, right? So that could be a way to mix the two things in a recommender system. But I don't know if you have like something more specific in mind, like a specific type of recommendations or in general. Yeah, well, so it could be a way. I think that could be an interesting thing. So right now we are sort of working on something like this. I can't tell you the results because we are still working on that. But I really think it's a promising alternative to try to, well, put some extra knowledge into that type of structures. Yes.
Thank you for the presentation. I really like your slides. It's very
Thank you.
interactive. My question is, could you give a summary on your perspective on the difference or pros and cons between this LLM KG and the current graph algorithms, such as graph neural network, etc., on tasks like link prediction? And why do you need to choose LLM when there are very good graph algorithms already? And if you can talk about like their performances or how you tune the model, their explainability, etc.
Great question, really. I really loved your question. So the thing is, so this system, like this is the system that was trying to combine the, well, maybe you don't see it from there, but I'll just read the thing that's written here. So this was the system that was trying to combine embeddings from knowledge graphs and embeddings from language models. According to the paper, it doesn't improve that much. Like, I don't remember the exact number, but it really was not so different from, like, if I just applied a knowledge graph embedding algorithm, classical stuff, the things that we talked about before, we would probably get more or less the same performance as with this system being applied. So the question becomes, like, is it because language models don't add anything? I don't think so. I think like there's just a lot of research to do in this area. Like, for example, this system just came out like 6 months ago. So like there's a lot of things to improve still. But my summary of the state of the art would be a lot of work to do. Like really a lot of work to do. But I think it's very, well, promising. The fact that like you could try to put textual information, textual knowledge there. I don't have a super specific answer because this thing, yeah, it's like ongoing, right? But I would say it needs a lot of work by a lot of people, a lot of smart people. So yeah, that would be my answer. Yeah, that is the, yeah? Good.
Any more questions?
You did a really great job distilling this information. I really enjoyed it. So my question is, I'm really interested in like the technical version of what you just shared. So are there any like talks that you've already given or anything that you've published that we can reference for the technical version of this? Or are you able to share the slides?
Well, I would, so this is the first slide, the first talk I gave on this thing. So no, there's nothing. That's the answer. But there's maybe this. I hope that helps a little bit, maybe.
I want the distill.
I mean, like, I'd love, like, if I had like more talks on this thing, I would just love to give you like some pointers. But this is the first time, so like it was a test. That's also why I asked you to give me feedback, because like now I have to tune the talk. You know, like I have to see if it was too technical, not too much, how to improve. I also don't know like about any talk that tries to summarize the whole thing in general, so I wouldn't be able to give you anything. I'm sorry. Next year, maybe. But yeah, those are like some of the papers that like talk about these things that we mentioned.
Thank you, Aldan. Salvi, thank you. Thank you for joining us today at the Data Science Festival. A huge thank You to all our speakers, volunteers, sponsors, and the AV team who has made this day happen. Please, could you help me give them a round of applause?